Hello, my dear children. Now, in the exercise 1.4, we are going to discuss these concepts or the following points. First one is Venn diagrams, and second point is operations of sets. Operations on sets. There are two types of operations. First one is union of sets, and second one is intersection of sets. These are called operations on sets. Third point, some properties of the operation of union. And the fourth point, we discuss some properties of the operation of intersection. And the fifth one, difference of sets. We are going to discuss all these 5 points one by one. Okay, my dear children? Right. Most of the relationships between sets can be represented means of diagrams which are known as Venn diagrams. Venn diagrams are named after the English logician John Venn. Okay, my dear children, he invented the Venn diagrams, the pictorial representation of sets. The relationships between the sets are represented diagrammatically. The diagrams are known as Venn diagrams. These diagrams consists of rectangles and closed curves, usually circles. In Venn diagrams, we use rectangles and circles. The universal set is represented by usually a rectangle and its subsets by circles. So, universal set, it is represented by a rectangle and we write like this U, universal set. And the sets in this, the subsets like this. Generally we use circles, closed curves, but in general we use circles to denote the subsets of the universal set. Okay, my dear children? Understood? Right. In Venn diagrams, the elements of the sets are written in their respective circles. Suppose here 1, 2, 3 are the elements of set A. We wrote the elements of the set A inside that circle. Similarly, 5, 6. Let us consider 5 and 6 are the elements of the set B. So we wrote the elements of the set B inside this circle only. Similarly, -3, 7, 9 are the elements of set C. So we write the elements of set C inside that respective circle. Understood this point, my dear children? Right. In earlier classes, we have learnt how to perform the operations of addition, subtraction, multiplication and division on numbers. Do you remember these operations, my dear children? Addition, subtraction, multiplication and division. We used these operations on a pair of numbers. Each one of these operations can be performed on a pair of numbers to get another number. For example, when we perform the operation of addition on a pair of numbers 5 and 13, between these two numbers, on these two numbers, on this pair of numbers, if you perform the operation of addition, we get a new number, that is 18. Similarly, if you perform a operation of multiplication on this pair of numbers, we get another number, 65. Okay, my dear children? Similarly, there are some operations which, when performed on sets, a pair of sets, give rise to another set. We will now define certain operations on sets and examine their properties. Henceforth, we will refer all our sets as subsets of some universal set. Okay, my dear children, we start the operations on sets. The first one is union of sets. We define the union of sets first. Okay, my dear children, right. Now we define union of two sets A and B. Okay, my dear children, let A and B be two sets. Then the union of sets A and B is the set which consists of all elements of A and B, the common elements being taken only once. The symbol U, this stands for union of sets, is used to denote the union. Symbolically we write A union B. Symbolically we write A union B and usually read as A union B. Understood the definition, my dear children? Now let us take an example to understand the union of two sets A and B. Okay, my dear children? Right. Now let us take an example to understand the union of sets. See here, let A is equal to set 2, 4, 6, 8 and B is equal to set 6, 8, 10, 12. These are the given two sets. We are finding the union of these two sets. Then A union B is equal to, first we write set A elements, set A union set B 6, 8, 10, 12. That is equal to, we write all the elements of A here and all the elements of B here. We combine all the elements of A and all elements of B. But you should note that here the elements 6 and 8 are written only once. We are not repeating the elements 6 and 8. We write them only one time. Okay, my dear children, understood this one? Right. Now we represent union of sets in the set builder form as A union B is equal to set of all x such that x belongs to A or x belongs to B. This is a set builder form of union of sets A and B, and we represent union of sets A and B in the Venn diagram as shown here. See here, first we have taken universal set. I represented here capital U, capital letter U, means it is a universal set. In this universal set, A and B are subsets of universal set, and I have taken like this intersecting circles to denote the union of these two sets. Just we have drawn horizontal lines joining the two sets A and B. This horizontal line shaded region denotes the union of sets A and B. Okay, my dear children, here this horizontal line shaded region, this horizontal shaded region denotes A union B. Okay, my dear children, right. Now come to some properties of the operation of union. These 5 are properties of the operation of union. the first property, A union B is equal to B union A. If you find A union B and B union A, they denote the same set. We get the result same. So this property is called commutative property or commutative law. Okay, my dear children. In the case of numbers also, you know, A plus B is equal to B plus A. The property is called commutative property. Now come to second property, A union B union C is equal to A union B union C. This property is called associative property. In the case of numbers, just to recall the properties, A plus B plus C is equal to A plus B plus C. That property is called associative property or associative law. Now come to third property, A union phi is equal to A. In the case of addition, A plus 0 is equal to A. Do you remember that property, my dear children? That is called identity, law of identity. Here phi is the identity of union. Okay, my dear children? Right. Now come to fourth property, A union A is equal to, again we get same set A. This property or this law is called idempotent law. Okay, my dear children? And the last property, universal set union A is equal to universal set only. This property is called law of universal set. Understood these properties of the operation union, my dear children? Right. Now come to the next kind of operations on sets, that is intersection of sets. We define intersection of sets is the set of all elements which are common to both the set A and set B, and we write it in the set builder form as, here this denotes intersection. A intersection B is equal to set of all x such that x belongs to A and x belongs to B. This is the set builder form of intersection of sets A and B. Remember this symbol, my dear children. This symbol stands for intersection. We represent the intersection of sets A and B by this Venn diagram. In this Venn diagram, this is a universal set. We represented the universal set by a rectangle and the subsets A and B by two intersecting circles. To denote intersection of these two sets, what is the first set? A. And what is the second set? B. So we are finding the intersection of two sets. We are representing the intersection of sets A and B in the Venn diagram. In that case, we have to draw horizontal lines in the first set, and in the second set we have to draw opposite lines, that is vertical lines. Then this portion, this part denotes intersection of A and B. This is the common part, isn't it, my dear children? Yes. So this shaded region denotes, this common part denotes the intersection of sets A and B. Understood, my dear children? Now we take an example to understand this concept. Okay, my dear children? Right. Now let us take an example to understand this intersection of two sets, okay, very clearly. Let us consider A is equal to set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the elements in the set A. Now B is equal to set 2, 3, 5, 7, 11, 12, 13. These are the elements of set B. Okay, my dear children. Now we are going to find intersection of these two sets. A intersection B is equal to, first we write set A, intersection symbol, set B. Now we have to observe, we have to find which are the elements, which elements are common in both A and B. See here 2 is there, here also 2 is there, so we write that element here. 3 is there, and here also 3 is there, so that is a common element. 5 is common element, and 7 is also common element. Only these 4 elements are common to the both sets A and B. Therefore A intersection B is equal to set 2, 3, 5, 7. Understood, my dear children, how to find intersection of two sets? Right. Now come to some properties of operation of intersection. These 5 properties are the properties of operation of intersection. So first property, A intersection B is equal to B intersection A. This law or this property is called commutative law or commutative property. And second property, A intersection B intersection C is equal to A intersection B intersection C. This property is called associative property or associative law. Third property, phi intersection A is equal to phi. Universal set intersection A is equal to A. These two properties are called law of phi and universal set. Okay, my children. Now fourth property, A intersection A is equal to A. This property is called idempotent law or idempotent property. And the last one, fifth one is A intersection B union C is equal to A intersection B union A intersection C. This property is called distributive property or distributive law. In the case of numbers also, you know distributive property, A into B plus C is equal to AB plus AC. Similarly here, this property is called distributive property or distributive law. Okay, my dear children? Right. Now let us discuss the next kind of operation on sets, that is difference of sets. Suppose A and B are any two sets, then A minus B is the set of all elements, which belongs to A but not to B, and we write A minus B. This is a difference of two sets A and B. In the set builder form, we define like this: set of all x such that x belongs to A and x does not belong to B. This is the set builder form of A minus B. And we can represent the difference of two sets in the Venn diagram as shown here. See here, I have taken universal set as rectangle, and two sets A and B are subsets of universal set. Then A minus B, these two are intersecting circles. Then A minus B, this horizontal line shaded region denotes A minus B, this part only. In the set A, we remove common part, that is A intersection B. The remaining part is A minus B. Similarly, this in this Venn diagram, B minus A, I represented B minus A in this Venn diagram. In the set B, we have shaded this part only. We have deleted the common part of A and B. Understood, my dear children? Right. Now, to understand the concept of difference of two sets, let us take an example. See here, let A is equal to set 1, 2, 3, 4, 5, 6, and B is equal to set -2, -1, 0, 1, 2, 5, 10, 12. Now, how to find the difference of two sets A minus B? A minus B, I wrote here, A minus B is equal to, I wrote first set as it is A minus second set B as it is. Now, we have to identify the common elements in both A and B. one is not one is common element, then strike out one here, one strike out the common elements in both the sets. 2 is common element here, 2 is common element, and here 5 is a common element, here also 5 is a common element. We have to strike out the common elements both A and B. After cancelling the common elements, what are the elements left in the first set? 3, 4, 6. 3, 4, 6. That's all. We should not consider the elements in the second set which are left after cancellation. Understood this step, my dear children? First we have to identify the common elements in both the sets A and B, and we have to strike out that common elements. After striking out the common elements, what are the elements left in the first set? We have to consider those elements only. In the first set 3, 4, 6 are left after cancellation. But in this second set -2, -1, 0, 10, 12 are there. But we should not consider these elements in writing the A minus B. Okay, my dear children. So set 3, 4, 6 is the B minus A. Similarly, let us find B minus A. B minus A. B minus A. -2, -1, 0, 1, 2, 5, 10, 12. Minus A. 1, 2, 3, 4, 5, 6. I am going to find B minus A. So I wrote first set B minus set A. Here also the same rule. We have to follow the same rule. Strike out. First identify the common elements in both A and B and strike out that common elements. You know, here 1 is common element, here 2 is common element, and 5 is also common element. After striking out the common elements, what are the elements left in the first set? We have to write them only. -2, -1, 0, 10, 12. These are the elements left in the first set after cancellation. We should not consider these elements in the second set. 3, 4, 6 are left in the second set after cancellation, but we should not write here. Only the elements which are left in the first set after cancellation, we should write only those elements. This is B minus A, and this is A minus B. Understood, my dear children? How to find the difference of two sets? How to find the difference of two sets A and B? Understood the concept of difference of two sets, my dear children? Right.